the other question I have for you is, how does memory play into all of this? Because all the signals sending back and forth, that's kind of like that's computation and communication, but that's kind of like processing of inputs and outputs to produce outputs in the system. That's kind of like maybe reasoning. Maybe there's some kind of recurrence, but like, is there a storage mechanism that you think about in the context of neuromorphic computing?
Yeah, absolutely. So that's got to be central. You have to have a way that you can store memories, and there are a lot of different kinds of memory in the brain. That's yet another example of how it's not a simple system. So there's one kind of memory, one way of talking about memory, usually starts in the context of Hopfield networks. You were lucky to talk to John Hopfield on this program, but the basic idea there is working memory is stored in the dynamical patterns of activity between neurons, and you can think of a certain pattern of activity as an attractor, meaning if you put in some signal that's similar enough to other previously experienced signals like that, then you're going to converge to the same network dynamics, and you will see these neurons participate in the same network patterns of activity that they have in the past. So you can talk about the probability that different inputs will allow you to converge to different basins of attraction. And you might think of that as, oh, I saw this face and then I excited this network pattern of activity because last time I saw that face, I was at, some movie, and that's a famous person that's on the screen or something like that.